When positioning, rotating, and scaling the objects in our scene, an important tool is the various sets of axes available in Blender. An axis acts somewhat like a ruler, helping to define any point in space. However, unlike a ruler, where 0 is marked at one end, 0 is marked in the exact middle of an axis. In a horizontal axis, distances to the right of 0 are assigned positive values, while values to the left are negative. And while a ruler is of a fixed length, an axis is, in theory at least, infinitely long. The horizontal axis is named the x-axis. When we want to measure positions and distances in a two-dimensional space such as a piece of paper, or a computer screen, we make use of a second axis, known as the y-axis. This axis is vertical with 0 again marked in the middle. This time, positive value measurements are placed above the 0 and negative ones below. The two axes intersect at their 0 points. This position is known as the origin. To determine the position of any point in our two-dimensional space, we measure its distance along the x-axis and then along the y-axis. This gives us the coordinates of the point. Coordinates are always shown enclosed in parentheses and the order x distance, then y distance, separated by a comma. In three-dimensional space, a third axis, the z-axis, is added which is perpendicular to the other two axes. As we might expect, 0 is at the center of the new axis and the axis is placed so that 0 occupies the same position as on the other two axes. As we can see from this diagram, representing all three dimensions on a two-dimensional screen is difficult. It looks as if the new axis is at 45 degrees to the other two, when, in reality, it is perpendicular to them. But if we look at the corner of any room in our house, we can see an example of all three axes. To help us visualize the relative position of each axis, we'll create a simplified version of them in Blender itself. In this image the x-axis is shown in red, the y-axis in green and the z-axis in blue. In fact, these are the colors that Blender itself uses for the axes. Notice that, as we change our viewpoint the z-axis is all but invisible as it points directly at us out of the screen. However, the direction in which the positive and negative parts are marked on the z-axis are not universally agreed, with some applications having positive values coming outwards while others have the positive values going inwards. So, make sure you are aware of the axis direction being implemented in any applications you may be using. To specify a position in 3D space, we give its distance along the x, y, and then z-axis. Blender muddies things a bit by swapping the position of the y and z axes so the z-axis is in the vertical position and the y-axis points in and out of the screen. Note that the positive end of the y-axis points inwards. The most important set of axes in Blender is the world axis. It is this set of axes that is used to measure and define the location of objects in our scene. In fact, when we start a new project in Blender, we'll see the x and y world axes displayed as a red line and a green line respectively. However, the z-axis does not appear. Because of our viewpoint at startup, both the x and y axes are visible. But if we change to the front viewpoint, the y-axis is now perpendicular to the screen and is no longer visible, but the z-axis is now displayed. When we place an object in 3D space, it is the center of the object that is used to specify the object's position. This point within the object is usually displayed as an orange dot in Blender and is referred to as the object's origin. As well as the world axis, every object that we place in our scene has two other important set of axes. These are the global axis and the local axis. These axes are always invisible within Blender, but if we create our own set of global and local axes, we discover three important points. The axes have their origins at the origin of the object. The two sets of axes occupy exactly the same space, and so we see only one set of axes for the moment. Each new axis is parallel to the equivalent world axis. If the object is moved to a new position in 3D space, its global and local axes move along with it. But, if we rotate the object, the local axes will rotate with the object, but the global axes are unmoved, remaining parallel to the world axes. As we'll see in more detail in a later video, We can choose which set of axes we want to use when we move, rotate or scale an object. For example, here we can see the rotated cube moving along its local z-axis. Another set of axes used in Blender is the view axis. Each object has its own set of view axes, with its origin at the object's origin. However, view axes are positioned relative to the computer screen, with its x-axis in the horizontal position, the y-axis in the vertical position, and the z-axis pointing straight in and out of the screen. Note that the positive end of the z-axis points outward. We'll see exactly how all of these axes are used in later videos.